start this session about developer experience by going at the lowest level, at the lowest level, at the compiler level. So I will present my work on trying to improve the cooperation between the OCaml compiler and the other tool in the ecosystem. So like many parts of my work, everything starts with a simple mistake. So for instance, adding a non-necessary argument to a functor application, which gives you a quite long and quite colorful error message. But it's quite probable that for many of you, you are more used to this version, which is a little less colorful. And that's strange. What happened to the color? Well, the problem is that from the compiler developer point of view, the error message is this nice algebraic data type. But when we go to the plain text output, and we lost a good part of this information, and sometimes tools resort to things like that to try to understand if what we are saying is an error or a warning. So it's a OCaml lecture that tries to match if the content on std would start with error or with warning. So there's kind of an impedance match here. So we have on one side nice structured information, on the other side we have ad hoc lexing. Fortunately, there is a well-known solution to this conundrum, which is to have machine-readable output with like JSON S expression. This is implemented by many compilers like GHC, GCC, Clang, Rust, and more. And it's a nice way to decouple the content of the compiler diagnostic from its presentation. So like this, editor can choose the best way to present the information present in the editor or other tools. So maybe it's time to end this talk. I mean, I just have to admit this, and everyone will be happy with this very nice readable XML. XML. Oh, do you mean that you didn't want XML? But maybe JSON. But I have heard that OCaml people quite like X expression. So maybe this one. And then there's something strange here. Do you see this last field, a footnote? A footnote in an OCaml error message. Does anyone have seen anything like that? Probably not, because it's a new feature, a new field in OCaml 5.3, which is not out, so probably no one has seen it. Which means that part of the problem is that we have an evolving compiler diagnostic, and if we want to improve the cooperation between the compiler and the tool, we need both to have a nice way to have an explicit versioning policing, so tool can consume the compiler output, and also a format-independent way to describe algebraic data type. Because, well, I'm an ML compiler writer. I don't want to write the JSON serializer. I would much rather describe what my IDT my algebraic data type are doing. So let's talk about subtyping and versioning policy. So the first very easy bit of versioning is just to add the error field. So like this, if a tool reads the fact that the metadata is as version 1, they can know that they are saying a compiler diagnostic that they understand fully. So which is nice, which means that I can write a tool that reads the version 1.0 of the compiler diagnostic, but then what about version 1.2 or version 2.0 or version 2.4.3? Well, for the last one, probably it's fine to ask the question, wait a minute, which sensor is it? But for the second one, version 2.0, if I've written a tool a few years ago, I would really like that my tool is still working. And even more so, if the compiler developer made a minor difference, really my tool should work without me having to do any kind of work. Otherwise, you will end up in a situation where every time the compiler update its diagnostic format and content, every tool needs to be updated, which is quite heavy and painful. So what should we do? Well,
this idea that a tool writes the right information, one m.x should be able to write a diagnostic function m.x plus k simply means that this later the update of the version should only refine other information to the previous compiler diagnostic. This is a classical notion of subtyping, which means that what I want is that minor update of the compiler diagnostic are subtyped or the previous version at the same major version. And it will be nice if both the compiler and the tool will be able to cross before future between later version and previous version. Unless from new version, because yes, from major version at some point maybe we want to add completely new information and no one can predict the future, so breaking version is kind of unavoidable. So, but let's try to precise a bit what I mean by subtyping. So the easy case is record, because for records, the classical subtyping rules tell you that you can add a new field to a record type, promote an option field to a required file, or deprecate a field. Why is it that? So for instance, imagine that I want to add a manual link to an error report to be able to point the user to, well, this error message is explaining summary in the OCaml manual. But if I have a tool writing previous version without this field, we will be reading, for instance, the kind of the error report. The fact that there's a new field somewhere doesn't matter for them. So this means that I can add this new field and consumer writing in the previous version just need to ignore the field, which is easy to do. The problem is with variant, because the dual of creating the new field for the variant constructor is to delete a constructor. Because, yes, if I have a sum type with some constructor, and I say that, well, no, I will never emit this constructor again, the consumer just ends up with some date code, but it doesn't need to implement anything, which works, but it means that every time I have a variant, I would be stuck with never adding any kind of constructor. And, well, I like my sum type and algebraic data type, and I will need to evaluate them at some point. So we'll need some more specific, let's say, more exotic subtyping rule for constructors. So first, easy rule to implement is to allow minor update to expand the argument type of a variant constructor. The third rule is to introduce a new derived variant constructor. So what does it mean? So let's go back to the example for deleting a constructor. I just remove a constructor, it's fine. What do I mean by expanding a constructor argument? So for instance, previously in my report kind, I have a report warning and a report warning as error. And then I have, and then if you look at the content of the argument of report warning was a concatenation of the warning number and the warning name. At some point, I would like to be able to split the two, to avoid the tool trying to parse this string to recognize the warning number and the warning name. So, and a nice way to do it is to decide, well, I would just expand the content of the argument of report warning from a string to a record that contains this special field content that would hold the previous content of the constructor, and then the new fields. And whenever a tool that was expecting to see a string, see a record, it knows that, well, I just have to look at the content field and my string will be here. So this works. But then it means that you can only provide more information under a variant. I can still not add a variant. So what can I do to add a variant? So the idea is that maybe I can try to find a compromise and say that my new variant constructor is not completely new. And it is, in fact, kind of similar to a previous existing constructor. For instance, I could add an int at a kind of error and say that if you don't know what is an int,
it's probably a little bit like a warning. It's not an exact mapping in terms of semantics, but for tool that only know about warning, it's better to have the information that there is a strange warning going around rather than just fail completely and pretend that nothing happened. So here, in terms of representation, this means that we first have the new constructor and an approximative field that say, well, if you didn't understand what was that constructor, you can try to read that as a report warning. And with this, we can at least add some constructor if we can approximate their semantic to previously existing constructor. So better than nothing, and there's many cases where, yes, int is a bit of a warning of alert. But let's try to speak a bit about the version 2.0. So when, at some point, you really need to delete fields that have not been used for 10 years or 20 years, or maybe at some point you really need to add constructors that have a completely different semantic than previously existing constructor, and then this means that you would need to have a major version update and say, well, I'm doing a breaking change, and I cannot avoid that without being able to predict all the features. But even in this case, there's still things that you want to do to preserve backward compatibility. In particular, you want to keep a set of deleted variant, constructor, and type to be certain that you are never able to delete a field named A, and then recreate, a few versions later, recreate a field A with a completely different semantic, because then people that would miss the delete could be very confused by the completely new semantics, and it's quite cheap to do. Okay, so we have a versioning policy. How do you implement that? So the main idea is to start from the algebraic data type and consider that I have an algebraic data type with version information. So for instance, with the information that this field has been created at version 1.0, this field has been created at version 1.0, then expanded, and I think and similarly for report. So this is a notion that is finer than what exists in OCaml. So what we can do is we can implement an embedded domain-specific language for describing version additive in compiler libs. With that, it's quite easy to log the additive that you are describing. And also, you can implement externally serializer, schema generator, versioning policy validators, and things like that. So how do you do that? So algebraic data type is the mixture of two features, type expression and nominal type. So for type expression, because we are only exposing data and quite simple data, you can use a standard GDT encoding that describes the type, that describes your type expression. So here we have a string argument, an int argument. We can combine then with list. There is this constructor that says that if you have a description of a sum of a record, I can create a field or a constructor with this content. And for the nominal side, well, you need to have fresh name for nominal type, and fresh name when you are embedded inside the language means fresh type. And fresh type, you can use a generative functor. So here it's a functor for creating a new record. So here it's mostly a history of version, some metadata information like the name of the new record, the generative argument, and then you have a new identity type, and some way to create new files, deprecate a field, delete it, make it required. So typically, if I want to describe the error kind of previously, I can create my new record and describe the fact that yes, I have a kind fields which contain a value of type kind, which will have been described previously, and I can describe my field like this. Then I can have a log type that mostly is taking some information, a printer, some setting for the printer, a version, a record type, a way to print on files or STD out and generate a log where I can log field by field partially to simply implement the serialization to the low-level device. And implementing a format implementation is just the classic printer for GLT. You match over the type description. You have some primitive for exposing all the fields defined in a record definition or destructuring a sum type. And it works. So typically, let me see if I can find, yeah. You can have a OCaml top level. Yes, that tells you that when you do 1 plus u, the output at the top level is the description that you have computed free. You have the metadata feed that is telling you that is the version 1, and it is fully valid. And you can also have warning if, for instance, if you never remember if it is running with a S or without a S. So this is a yeah, so it is without a S, and then you have a top-level error that tells you that the warning was an unknown directive, and you know about that the information came from the top level, and it is a top-level error that the compiler error inside the top level. And like I say, you can also implement JSON schema. Let's say that describing algebraic data type in a format that is not really aware of some type can be quite long. So this is the schema for the compiler diagnostic in full. But it's possible to do that. So this work, there is an upcoming PR for this work. Like I say, you can implement external tool for exporting JSON schema and validating the ADTA history or adding a new serializer. It's easy enough to add serializer that I could implement a toy XML validator between 2 sessions in ICFP, which is nice. And if you have feedback, they are more than welcome.
We have time for some questions. Okay, I can ask a quick question. So you're planning to do the translation from, transforming the schema from one version to the other version. Don't that put a lot of burden on, well, you, the compiler developer, to handle all this annoyance, which we sort of had to deal with, parse AST.
Yeah, so it's part of the problem that someone needs to deal with the annoyance, and the compiler is kind of a centralized place. And let's say that the compiler diagnostics doesn't change that much, so I don't expect to have that many change, and it could be automated quite easily. If starting really, you could have a generator that starts from the ADT description and output everything. It's most of the case. But yes, so and in fact, it would be quite nice to lift a lot of this declaration, this description at a meta level. But meta-programming in the OCaml compiler is quite heavy, so I wanted to start with embedded DSL and then possibly later generate things.
Okay. Okay, then maybe, no, go on.
So thanks, that looks cool. from what I remember from a few years back, a number of the errors at the output of the compiler were at the time fairly like in a string format, like already processed. Like a type error would just be, okay, actually you just got this error message and the structure has been lost. I guess this is somewhat orthogonal to your work, right?
Yeah, so it's still connected because one of our reasons to move to structured diagnostic is because, well, I would like, in fact, to have even more structure in the compiler side for error message, but already existing structures are already hard to process by tools, so it doesn't make sense to add structure when nobody would ever use it. But which means that once we have the structure, it would be easier to motivate people, or to probably to motivate me to have more semantic error messages, to expose really the error and not the processed strings. So some of the things that is not exactly shown here is that, in fact, the error message is already not outputted as a string, but rather that the format string that contains formatting information. So tool can see which tag were used and can re-implement them. And then they can redo the formatting to adapt the geometry, to not have an error message that was formatted for 80 colon wide terminal when you are in VS Code.
Yeah, that makes a lot of sense. Yeah, thanks.
So I was expecting to see just a great story for OCaml errors, and if I understand correctly, the story is much bigger, right? So it's common to see cases where you can define data structures and automatically derive serialization. But I haven't seen all the versioning logic being built in for you. So isn't this just a much bigger idea than what you're building it up to be?
Well, theoretically, it could be used by anyone. I'm cheating a little bit because for the OCaml compiler, I only need the serializer, not the deserializer. So it removes a little bit of complexity. But yes, otherwise, it's quite generic way to try to describe your algebraic data type in a versioned way. With some limitation, because yes, the type expression doesn't cover the full power of the OCaml type system, because once you try to explain GIDT inside GIDT, you are hurting yourself quite a bit. So, but most of the time for compiler diagnostics, you want to have pretty simple data type that can be pretty well, that can be printed. So,
thank you.
All right, let's thank the speaker. And